Hello and good afternoon for our presentation of our final project of work and energy. Today we will be presenting by Rafael Sureda and Jorge Gonzalez.
So what is work? Work is done when a force is applied to an object and the object moves in the direction of the applied force. In a situation like this, work, W, is defined as force per distance traveled, energy. There are three types of energy: kinetic energy, potential energy, and mechanical energy. The kinetic energy is defined as the energy of motion, and this energy it is known with the formula kinetic energy equals to the half of the mass times the velocity squared. The potential energy of an object is determined by the amount of work required to move it from one place to another. The formula is potential energy equals to the mass times the gravity times the height. The mechanical energy is the sum of potential energy and the kinetic energy of an object, and the formula is mechanical energy equals to kinetic energy plus potential energy.
Some facts that we found is that work is measured in joules, as is all the energies. The units of measurement of joules can be achieved by multiplying newtons times meters. Just as matter, energy cannot be destroyed or created. Potential energy has several forms. One of the most common is gravitational potential energy, which is the one we will be using. Therefore, the potential energy is measured from the y-axis.
Now we'll show you an everyday life example.
Now, after seeing the video, we will have a problem about work. It says, if the assassin is wondering the work that he did getting rid of the body, considering that he took an estimate of 7.76 seconds to do so, and pulled the victim 6.8 meters from its initial position. From experience, the assassin estimates that the victim's mass is about 60 kilograms. Come an accomplice and help him find his work. So we have that our data that is given to us is time, 7.76 seconds, the distance 6.8 meters, and the mass of 60 kilograms. Now we will obtain the velocity. We will use time and distance. We will use the formula of the position equals the initial position plus a half of the initial velocity plus the final velocity times time. Then we will find that the velocity after substituting every value on the formula will equal to 1.75 meters per second. Now we will find the acceleration using the time and velocity. So in this case, we will use the formula velocity equals initial velocity plus acceleration times time, which will be rewritten as velocity equals acceleration times time. And we will find that the acceleration is equal to 0.23 meters per second squared. After we find the acceleration, we will find the force, which we will be using the mass and the acceleration. The formula of force is equal to mass times acceleration, and the result we get is 13.53 newtons. Then we will find the work, which we will be using the force, which is equal to 13.53 newtons, and the distance of 6.8 meters. The formula of work is just force times distance, which gives us 92 joules.
Now we'll see another problem, now based on energy. And it states, if there was a police officer in the first floor, determine if they'd be able to perceive the falling body, given that the fall is from 7 meters and the average reaction time is from 273 milliseconds. Before we continue, I need to establish that the reason the fall is from 7 meters is because each floor has an altitude of 3 meters, and we're just adding another meter due to the white fence. Thank you. The data given is equal to gravity, equals to 9.8 meters per second squared. The mass has been mentioned before, and it's equal to 60 kilograms. And the height, as mentioned in this part of the problem, is 7 meters. So the first thing we have to do in order to find the time that the falling body will be able to be perceived from the first floor is obtaining the potential energy at its initial position, which the potential energy is obtained by multiplying mass times gravity times the height. And all of this data is already given, so we just need to substitute, which gives us an potential energy of 4,116 joules. Now we have to find the mechanical energy, which at its initial position is equal to its potential energy due to the fact that there is no kinetic energy at this point. Now we need to find the potential energy at 3 meters above the ground. So we follow the formula of potential energy, which is mass times gravity times height, which gives us the result of 1,764 joules. Now we need to find the kinetic energy 3 meters above the ground. And to find the kinetic energy using the mechanical energy and the potential energy, we just need to subtract the potential energy from the mechanical energy, which gives us 4,116 minus 1,764. And the final result of this is 2,352 joules. With this information, we can now find the initial velocity 3 meters above the ground. We have to, using the kinetic energy formula, isolate the velocity, which gives us a now formula of velocity equals the square root of 2 times the kinetic energy divided by the mass. The final result of this equation is 8.85 meters per second. Now we need to obtain the final velocity, which is just before touching the ground. For this, we need to use the mechanical energy as if it was the kinetic energy, because at this point, the velocity is at its maximum point. So we just isolate the same way we isolated before. And now we have that velocity is equal to the square root of 2 times 4,116 divided by 60. The final velocity is 11.71 meters per second. And now, using the formula, final position equals to initial position plus the half of initial velocity plus final velocity times time. We can isolate the time variable and just solve time equals 2 times final position minus initial position divided by the initial position plus the final position. Now, substituting the variables, we get that time equals to 0.292 seconds. And from the data given at the beginning of the problem, we know that the average reaction time is of 0.273 seconds. So we can say now that the police officer has enough time to perceive the victim's falling body.
Thank you for your time and hope you enjoyed our presentation. I hope you learned a little bit about work and energy.